Alright, we're going to be looking at notes on synthetic substitution and division. Alright, so we're going to look at synthetic substitution first. It's an alternative to direct substitution. So we're asked to evaluate f of 2 for the following polynomial. So when you start raising to a power, your numbers get large quickly. So synthetic substitution is a way to kind of keep your numbers a little bit smaller. Alright, so the first thing we do is write down the coefficients for our polynomial in standard form. Now notice that we don't have a x term here, so we have to put in a 0 placeholder for that term. Otherwise, synthetic substitution or division won't work. So you've got to remember your 0 placeholders. Alright, so once we write down the coefficients, we're going to evaluate f of 2. So on the outside here, we're going to put our 2. Alright. So here's our step. We're always going to bring down the first term. Then we multiply 2 times 2 and get 4. 3, and then we're going to add and then repeat. So 3 plus 4 is 7. So multiply, add, multiply, add, multiply, and add until we run out of terms. Now this is our answer. So f of 2 is equal to 35. And if we were to substitute 2 into each one of the terms for x, we'd get the same answer. So it's just a different method for evaluating a function at a given x value. Alright, so let's practice this a couple of times. Alright, remember we got to have 0 placeholders. So get yourself set up. So negative 2, because we're evaluating when x is equal to negative 2. Alright, write down your coefficients. So negative 4, make sure it's in standard form. 3, my x term is missing, so I'll put in a 0, and then negative 7. Drop the first term, multiply, add, multiply, add, multiply, and then add. So f of negative 2 is equal to 37. Alright, let's set up the part B. So we're going to put negative 1 on the outside because we're asked to evaluate f of negative 1. Alright, it's in standard form, but I'm missing some values. So I got negative 4. There's no cube term, so I'm going to put a 0. I've got negative 1. I've got a 2, and I don't have a constant term. So I still have to put a 0 placeholder in for that constant term. Alright, drop the first term, multiply, add, and repeat. Multiply, add, multiply, add, multiply, and then finally add. So f of negative 1 is equal to negative 7. Alright, so synthetic substitution. Alright, let's look at another application of synthetic. We're going to use it to factor a polynomial. Alright, so we use this to factor a polynomial that doesn't factor in traditional terms. Like this is 4 terms, I would look to see if I can factor by grouping, which it doesn't. Okay, so that's why it's sort of like completing the square for polynomials, called synthetic division. Alright, we're going to start you off with one. We're giving you a freebie. So we're telling you that one of the factors is x plus 2. We know we're going to have 3 factors total, so we're asking you to find the other 2 factors. Alright, so if x plus 2 is a factor, that means that x is equal to negative 2. So when we set up our synthetic, we're evaluating this thing at negative 2. And because it's a factor, that means it's a 0. We know our remainder should be 0. That's what that theorem is saying. Alright, let's look at it's in standard form. We're not missing any terms. So write down the coefficients. And let's do synthetic. So we're going to drop, multiply, add, multiply, that's an 8, add, and multiply, and we should be getting 0. So that makes us happy. Alright, now what we've done, we've divided by x. So we had x to the third, and we divided by x. So that makes this an x squared. This is a quadratic. It has a degree of 2. So we have to turn this thing back into a polynomial. And we're going to factor that. All right, so what multiplies to give us negative 24, but has a difference of negative 10? All right, so what? Negative 12 and 2. So let's rewrite that middle term. And I'm just factoring by A times C method. So pull out a 3x, pull out a 2. So that means my other two factors are x minus 4 and 3x plus 2. All right, so there it is, completely factored. The biggest mistake people make on this is forgetting about the freebie. So always make sure you include that as part of your final answer. All right, let's look at another example. Solve the polynomial. We're solving. That means we're going to find x, find the zeros, find the roots. All right, solve the polynomial. All right, we're starting you off. We know we have 3 total, and we're starting you off with the first one. You got to find the other 2. So that means here that x is equal to 3. So get yourself set up with synthetic. All right, am I missing any terms? Nope, it's in standard form. So write down your coefficient. And I know my remainder should be 0 when I get here, if I'm doing it correctly. All right, so let's do synthetic. Drop, multiply, add, multiply, add, and multiply, and a remainder of 0. So I'm happy. All right, here again, it was a cube. We took an x out, so essentially we're dividing by x. So this is going to leave us with a degree of 2. So turn it back into a polynomial. And we're solving, so we're going to set it equal to 0. All right, let's factor this. This is the A times C method. So what multiplies to give you 40, but adds to give you 8. All right, so it doesn't factor. All right, so what are our other options? We can either complete the square or use the quadratic formula. I'm going to complete the square. All right, so let's complete the square. So I'm going to isolate. All right, lead coefficient is 1, so I can find C. C is going to be half of B squared. So 4 squared, which is 16. Add that to both sides. Factor this. So it's going to be what multiplies to give you 16, but adds to give you 8. Should be 4 and 4. So that's where we get x plus 4 squared. Combine these terms, you get negative 24. Square root both sides. So I'm going to, this is a negative. I'm going to, under square root, I'm going to get I. So I'm going to imaginary. And subtract the 4, and then simplify. Well, it's 4 times 6, so 2 square root of 6i. So I have one real solution and 2 imaginaries. And notice my imaginaries are conjugates. That always happens. You can't have one imaginary solution. You've got to have the imaginary solution and its conjugate. All right, solve. We're asked to solve the polynomial given that 3 zeros. So that's an x-intercept. So that means one of our zeros is 3. I'm looking for 4 total. All right, so I've got 3. I got to find 3 more. All right, let's start with synthetic and see what we get. All right, I'm not missing any. Oh, I'm missing the square term. So 1, negative 3, 0, 8, and negative 24. All right, here again, I should be getting 0 as my remainder. All right, drop, multiply, add, multiply, add, multiply, add, and then multiply, and I'm getting 0. All right, so what do we have left? This was a degree of 4, so that means that I've taken an x out. X to the 4th divided by x gives me x to the 3rd. So that means this is going to have a degree of 3. So when I turn this back into a polynomial, I'm going to get x to the 3rd plus 0x squared plus 0x plus 8. Well, I can simplify this to x to the cube plus 8 equals to 0. So now we need to factor this. Remember, I'm looking for 3 solutions. If I isolate, I'm only going to find the real solution, so I have to factor it. This is the sum of cubes. All right, so my first term is x, and my second term is the cube root of 8, which is 2. It's a sum, so I'm going to get x plus 2, square, opposite multiply, and then square the second term. All right, so my real solution on this part right here is negative 2. I can add that to my list so it touches the x-axis twice. And these two, this is not going to factor, so I'm going to get 2 imaginary solutions. So I'm going to complete the square or use the quadratic formula. All right, I'm always going to choose complete the square. So let's isolate. Find c. All right, my lead coefficient is 1, so I can just take half of b squared, which gives me negative 1 squared, so I'm adding 1 to both sides. Factor. Combine my like terms. Square root both sides. Don't forget my plus or minus. Square root of 3, it's negative, so there's going to be an I. And then move the 1. All right, so my 2 imaginary solutions are 1 plus or minus the square root of 3i. So that makes my 4 solutions. All right, find an expression for the missing dimensions. All right, so this is a cube. So I know the volume is length times width times height. All right, so so that means that x equals negative 6 is a 0 and x equals 1. All right, I can start with pick one of them. I'm going to use the negative 6 first. Set up your synthetic. As long as I have factors, I can keep using synthetic. All right, I'm not missing any terms. It's in standard form. Since this is they're telling me that's a factor, I know my remainder should be 0. All right, let's do synthetic. Drop, multiply, add, multiply, add, multiply. All right, since I have another factor, I can use synthetic again. So this time with the 1. So do synthetic again. I get 1, multiply, add, multiply, and there's my 0 again. All right, so this is going to be my remaining factor. All right, what's the degree of this? This had a degree of 3. We took an x out. This has a degree of 2. Took another x out, so this has a degree of 1. So that remaining factor is going to be x plus 8. That's my unknown factor there. Plus. All right, we're going to find all the zeros of the following function. Notice we don't start you off with any, so you're going to have to find them. How many are we looking for? This is a degree of 5, so we're looking for 5. We're going to use Desmos to help us find the real solutions, and then we'll find whatever's left, the irrational or the rational solutions, and then we're going to, they might be irrational or they may be imaginary. All right, so in Desmos, we're going to type in that equation. All right, so in Desmos, it looks like the following. All right, so we want to get the real zeros off of this, or their rational zeros. So if you click on, it's going to highlight you can find your real zeros. In this case, our rational zeros we're looking for. All right, so we got negative 2 is a 0, and then 1 is a double root. So we got to count that twice toward our total of 5. So that's what we're going to do, start with our synthetic. So we got negative 2, and then we count 1 twice. All right, so we've got, all right, negative 2, and then 1 is a double root. And we've got to find 2 more. All right, let's use synthetic. I can start with my negative 2, or I can start with my 1s. All right, am I missing any term? I'm missing the cube term. So 1, negative 2, 0, 8, negative 13, and 6. and I should be getting a 0 remainder because this is a 0. All right, 1, drop, multiply, add, multiply, add, multiply, add, multiply, add, and multiply, and I'm getting 0. All right, I'm going to just continue on with all the zeros that I have, so I'm going to use 1 next. So drop, multiply, add, multiply, add, multiply, add, multiply, and I should be getting 0 again. Because 1 is a double root, I'm going to use 1 again. So drop, multiply, add, multiply, add, multiply, and I get 0 again. All right, now this, I know I'm going to get 2 imaginary solutions because the graph only touched the x-axis twice. All right, what degree is this? Well, this was 5. Take an x out, we're 4. This is a cube, so this is going to be a square. So if I turn this back into a polynomial, I'm going to get x squared minus 2x plus 3 equals to 0. All right, this doesn't factor. Nothing multiplies to give you 3, but adds to give you negative 2. All right, so I'm either going to have to complete the square or use the quadratic formula. Well, I'm going to complete the square. So I'm going to isolate, find c. So c is half of negative 2 squared, which is 1. Add that to both sides. Factor, add, square root both sides. All right, I'm going to get square root of 2, and because it's negative, I get an I. So my other 2 solutions are 1 plus or minus the square root of 2i. So 1 minus the square root of 2i, and 1 plus the square root of 2i. Okay? All right, let's do one more like this. So we're going to use the calculator again. So let's put this in Desmos. So in Desmos, all right, so our zeros, looking for 4 total. All right, what do we got? Negative 3 and negative 1. So we can start our synthetic with negative 3 and negative 1. So that means our 2 other ones are imaginary. All right, so let's do that. Negative 3 and negative 1. All right. So negative 3, negative 1, and I got to find 2 more that are imaginary. All right. So I get negative 3. 0 placeholders? No. So let's write down all our coefficients. And since it's a 0, I should be getting a remainder of 0. All right, drop, multiply, add, multiply, add, multiply, add, multiply, and I'm getting a 0. All right, let's do synthetic again with my negative 1. So drop, multiply, add, multiply, add, multiply, and I'm getting my 0 again. All right, what degree are we? Because I've used this. This is degree of 4, degree of 3, so this must be degree of 2. So this is going to translate to x squared plus 0x plus 4, which is x squared plus 4x equals 0. All right, solve it. Square root both sides. Don't forget your plus or minus. Square root of 4 is 2, and because it's negative, I got an I. So here are my 4 solutions. Negative 3, negative 1, negative 2i, and 2i.